Here's another mechanism for another virtual parameter, parabola, again due to Cramer, figure 284 in my book here. There we go. It's not quite as complicated as it looks, because the top part is simply a pantograph mechanism used to generate the midpoint between 2 points. And so we won't bother actually drawing that. We'll just use a midpoint construction. Okay, so here is the mechanism figure 284. What we're going to have is a crank, and it's going to be pushing a vertical line backwards and forwards so that we create a vertical line through B. Again, I tend not to draw these vertical to start with, but I want to make sure I put the constraint in to make it happen. So there we are, we're now vertical. This crank is a particular length, A, and it's going to have to be driven by a crank angle, theta. So as theta changes, the vertical line is going to come backwards and forwards. We now have a second crank, which comes up like this, and it is of length 2a. And its distance to A from the distance, sorry, A from the origin. And now what we're going to do, the mechanism itself then has a pantograph, which is able to construct for us the midpoint between D and B. But I'm just going to use my midpoint construction. And E is then what we want to trace as theta varies. And so there we see the curve that E follows. Now again, there's going to be a second related curve to this. If we put a second piece, oops, I missed the line. Let's just make those incident and make this length 2a. Then again, the midpoint between B and F. And we could look at the locus of that as theta varies. And we get, if you like, the second half of the curve. What is the curve? And let's just make sure the two bits are the same, viewed implicitly. And there's no surprise there that they are in fact. So there is my little mechanism for creating this virtual parabola. We can animate it over theta and watch it do its thing.